So again, what we're looking for is the general slope equation. So what we've done so far, this is going to be general slope equation of curves. General slope equation, an equation that's going to describe the slope of the curve. So far, what we know is that if you have a curve, right, we can find the slope of the curve at a certain value A. Right? So far, what we have found is we have found the slope of a curve at a specific location. It's the limit as x approaches that specific spot of f of x minus f of a over x minus a. We can find the slope at a point on the curve. That's what we've done so far. Look at a certain spot, right? A certain location. We have like an xy value here, right? This is our x value, or I should say, this is a comma f of a, right? A certain location in the function, a certain value, right? Of this function f of x. We can find the slope at a certain point of this equation. And that's good, right? If I want to know the instantaneous rate of change at a certain point, right? This slope is also the instantaneous rate of change, aka instantaneous rate of change. Instantaneous rate of change. And that's all fine. But what would be nice is, what if I want to find the slope of this curve over here? What if I want to find the slope right there? Or here? Or the slope of the curve here? What if I wanted to do it somewhere else? I would need to redo this calculation over and over and over again. If I want to find this slope, or this slope, or this slope, I would need to redo the calculation over and over again. To find these, we have to redo the calculation. And that's really annoying. Over and over again, right? Over and over again, redo the calculation. It would be nice. It might be nice. It might be nice. Anyone watch Hamilton, by the way? It might be nice. You watch that movie. It's a good movie. Hamilton. Anyway. It might be nice. It might be nice to be able to have an equation to find the slope. All right, everyone? Good show. So it would be nice if we had an equation that would tell us the slope of any point. If I can plug in, if I can like figure out a formula to like plug in the x value and out comes the slope. Plug in the x, out comes the slope. Right? That would be nice. That would be nice. Yeah, yes, Angel. Hamilton, not Hamlet. Hamilton. Although, I don't know, maybe your history class you were talking about Hamilton. I don't know. Anyway, it would be nice. Let me write this down. It might be nice. It would be nice. Be nice. To have, nice. To have, not the to have an equation. Have a, what we're going to call like a slope equation. A slope equation that tells us the slope, the tangent slope, I should say, the tangent slope at any x value. Might be nice to have an equation that tells us the slope, the tangent slope, at any x value. Where all we have to do, all we would do, oh God, all we do is, all we would need is to plug in the x and get the slope. That would be nice. It would be nice to have some kind of slope equation, a formula, an equation that tells us what the tangent slope is at any x value. You plug in the x value, you get the slope. That's what we are looking for. And some smart people like Newton and Leibniz, back in the 1700s, figured out a way to do this. They figured out a way to make this equation. We do. Whoa. We do have this. We do have an ability to find this. And the slope equation is equal to the following formula. It's going to be the limit as h approaches 0 of f of x plus h minus f of x over h. Good, need. So that is our equation. This formula here, the limit as h approaches 0 of f of x plus f of h, f of x plus h minus f of x over h. This formula here gets us this slope formula, this equation. It's going to have an x left over. Will have an x left over. It's going to equal an equation. It's going to equal an equation. It's going to have some x's left over in the equation, perhaps some values left over, telling us what the slope is anywhere on the graph. It's going to make an equation, not a number, not like 6. It's going to be maybe 6x plus 5, or 2x squared minus 3. You do this formula, it's going to get you an equation out of it. And that equation, the x value, you plug in that equation, tells you the slope. So what is this h situation? What is this thing going on here? This formula, the way it works, is what we're going to say is, if you have a graph, right, some curve, okay, whoa, some curve. Let me try to do a little bit better. Some kind of better looking graph. There, that's great. And we're going to have some x value. Right, this is our variable. I want to know the slope anywhere, so I use x. and I say, I want to know what the slope is at this x value. What is my tangent slope here? X can be any number. I leave it as x, I leave it as a variable. What we do is we imagine there's kind of a little space here, a little gap. We go to some kind of next point, and this space here is h. And so this like second value is x plus h, right up here, right? So we imagine some location, and we imagine some addition to that location called h. We move a little bit to the right. We have some value x, and we say, well, what if I took another point slightly far away, a little bit far away from x? Call it x plus h, right? Because when we find a slope, let me zoom in here. When we find a slope, we need 2 points, right? Need 2 points for slope, right? So we have 2 points. This first x location is our first point, and then x plus h, a little bit of like a little space between the first point and the second point. So what we're finding is the slope. We're finding the slope between these 2 points. The slope of this line is, well, it's our slope formula, y2 minus y1. So f of x plus h, my little second point, the far away point, minus f of x, right, minus our first point. So that's the change in y, right? This is the change in y. y2 minus y1 over x2, which is x plus h, minus x, right? My x2, x1, x2, x1. It's a slope formula. It's the equation for slope, right? The slope of this red line here is my y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. The change in y divided by the change in x. Change in y divided by the change in x. Mathematicians like this concept of change a lot. They like to understand what this, like, that things change, that things like adjust, right? So instead of saying y2 minus y1, sometimes you'll see this as written like delta y. This is the Greek symbol called delta, and it means change. And this is just like, so y2 minus y1 is the change of y, right? How much did y change? And the x value here, the x change, right, that's delta x, same thing. So delta y, delta x, right? This delta x value, this is the change in x, right? Some change, some amount of difference, right? So if we simplify this equation, right, we see that f of x plus h minus f of x over x plus h minus x. Well, the h's here, the x's rather, this x is going to cancel with this x, right? X minus x. So I'm going to get f of x plus h minus f of x, oh goodness, of x over h. And that's the slope of my, like, this secant line, this red line here. Imagining there's 2 points kind of separated by a little bit, separated by this little space h. And we have a slope, right? y2 minus y1, the f of x plus h, right? That's up here. Right here is f of x plus h, right? Like let's say x was 2, h is like 0.1, this is 2.1, right? Some small amount. Small amount to the right of x. Small amount, a little bit bigger. And then right here, this is f of x. Right, so my change in y, this right here is delta y, and this right here is delta x. The space between them, right? Change in y over change in x. Because you'll see these symbols being thrown around by people. I want you to understand what these triangles mean, what the delta means, what this space means. Delta just means a small amount of change. Delta just means a small amount of change, some space. Okay? And so we find the slope of this line by finding the slope between the 2 points, right? Same equation as like your regular slope formula. And it becomes this f of x plus h minus f of x over this h, because our x is canceled out. Right? We have this h. So what we can do then is, okay, this is the equation for the slope of this red line, but I want the green slope. I want the slope of this green line just at the single value of x. I want the slope at a point. So what we do, the trick that they came up with was, well, what if I took this delta x, this h value here, this small difference, and I shrank it down until it was equal to 0. And I shrank that space between the 2 points, I shrunk it down until there is no space, until it's just a single point. Then I have the slope at that particular spot. And that's what they do with the limit. That's what we've done with this limit. So the slope of the green line, the tangent slope, let's see, this is my red slope, right? If I take the limit of this function as it approaches 0, the tangent slope is the limit as that h value approaches 0 of f of x plus h minus f of x over h. So as my h gets smaller, as my distance between the points disappears, it becomes 1 point, and I have the slope at that value. The space between the points shrinks to 0. This h value, the space between those points, shrinks to 0. And that's how we get the slope at a value, at a single point. So that's what this delta x, sometimes you see it as delta x, sometimes you see it as h. Same idea, same concept, it's this separation. That separation shrinks to nothing, and now we have a slope at a point. And because our point is x, or because our point is a variable, we get an equation for an answer. Get an equation for an answer. Okay? So that's the idea behind what this situation leads to here. That's the idea. The slope equation comes from this limit as h approaches 0 of fx plus h minus fx over h. So let's put this into practice. Let me show you an example of what would happen in a situation. For example, let's find the tangent slope equation, tangent slope formula or equation of y equals x squared plus 2. Okay? I'm going to find the tangent slope equation of this formula here. So what I want is this graph, just quickly this graph, x squared plus 2, looks like this, kind of. Hold on, let me try that a little bit better. Looks like this. Here's 2. And I want to know what is the tangent slope at any point along this graph. What's the equation that tells me the tangent slope anywhere along this graph? At various x's, I want to know what the tangent slope is. Tangent slope equals what? I want to know the tangent slope for various points. So we're gonna make an equation. We're gonna make a tangent slope equation. We're gonna say, okay, that equation, the slope equation, tangent slope equation is going to be the limit as h approaches 0 of f of x plus h minus f of x over h. Watch what happens. Watch how we do this. This x plus h, the whole thing, is going to be plugged in to my x formula. Plug in x plus h, that whole piece. So what we're going to get is, if I plug in the equation, limit as h approaches 0 of the equation is x squared plus 2. So I'm going to put x plus h squared plus 2. And that's my first piece, right? This is like the first chunk. That's this f of x here, this f of x plus h, right? This piece right here, I plug in the x plus h into the x, right? I get the equation, the x plus h in there, okay? Minus, this is just the regular equation. But regular equation. I just use the next piece is x squared plus 2. Regular equation. I just use the whole formula, the regular formula. I don't plug in something crazy. The first one I have to plug in the x plus h into the x. Right? I use the x plus h. Second one's just a regular equation. Over h. So step 1, plug in. Step 2, simplify. We're going to just simplify this equation. So I've got x plus h squared plus 2 minus x squared minus a. I have to do some simplifying. I got to distribute some things. I have to multiply some stuff, right? So I'm going to distribute this negative to these pieces. And x plus h squared, what does this become? Is it x squared plus h squared, everybody? Is that what it is? X squared plus h squared? Is that right? Please don't make me kill a puppy, everybody. Please don't make me kill puppies. No, that's not correct. No. Please don't make me kill puppies. No, that is not correct, right? When you have a squared, it means there are two of them. X plus h times x plus h, and I need to distribute. Maybe I should do this. Hold on. Maybe I should do this somewhere else. Hold on. I'm going to do it down here. That means x plus h times x plus h plus 2 minus x squared plus, minus 2 over h. So now I'm going to distribute the x plus h. Got a lot of letters now. This is fine. We just do our math the same way as normal. We're going to get limit as h approaches 0. X times x is x squared. X times h is plus xh or hx, whichever you prefer, plus another xh plus h squared. Okay, that's fine. Plus 2 minus x squared minus 2. All right, I just distributed my x squared, this whole thing, got this whole equation. Now I'm going to simplify a little bit more. I noticed that some of these things are similar, right? This 2 right here, 2, and minus 2. Just like before, this 2 is going to cancel with this 2. I also notice I have x squared minus x squared. X squared minus x squared. Those x squareds are also going to cancel. And like we did before, you will see this pattern repeat a lot. Many of the pieces of this equation are going to cancel each other out, leaving you with just the parts you need. So let's keep going. Limit as h approaches 0 of xh plus xh is 2xh. Right? These two combine together. Plus h squared over h. Right. It's okay so far? So far so good? Got all these pieces. We did our h situation. We got this h here. Distribute the h, do all kinds of stuff, right? The problem still is when I do my limit, I'm going to get a 0 on the bottom. So I really have to cancel this h on the bottom. I really have to cancel this h on the bottom. When we're doing this whole process, that's our singular goal. How do I cancel this h on the bottom? How do I simplify this? Any ideas of what we can do right now? Any more simplifying we can do? Anything can cancel one of the h's on the top? Yes. Well, which one? This one or this one? This one or this one? I got one h here. Which one? How do I cancel? Cancel one of them? Am I only allowed to do one of them? The one that's squared? Only this one? This one, I have to leave this one alone? I only cancel this one? Isn't it both? Yes, Jessica, thank you. Both. I cancel one of each, right? What happens here is I have a GCF of h. They both have h's, right? I can't pick and choose. I got to do both. Right? When I cancel something on the top, I have to cancel it from both. So what I'm going to do is GCF factor out my h. GCF factor out my h. I'm going to get the limit as h approaches 0 of h times 2x plus h over h. And now my h's can cancel. And you'll see that's a very common thing that you do. You GCF factor out an h. Your h's are going to be kind of like somewhere repeated, and you'll factor it out. You'll get rid of it, and that'll be how you cancel. So we canceled our h, and now we have oopsies. And now we have the limit as h approaches 0 of 2x plus h. And if I plug in the limit, that's just going to be 2x plus 0, which is just 2x. And this is my tangent slope equation. This equation will tell me the slope of any tangent line. Where's my graph? This equation will tell me the slope of any tangent line. I plug in an x, I get the slope. It's going to tell me all these green tangent slopes. At any x I want, I plug in the x, it's going to get me the slope of the tangent line at that spot in the graph. Beautiful equation. Just gorgeous. Look at that. 2x, simple, beautiful equation. Going to tell me the slope anywhere along this curve. So I can ask questions like, what's the slope? What's the tangent slope? What is the tangent slope at x equals 3? What's the tangent slope at x equals 3? Well, I know that the slope equals 2x. So I'm going to plug in a 3. That's going to be 2 times 3. That's going to be 6 is the slope. Right? That's it. Plug in the x. In this equation, you get the tangent at that point. No need for our formula. No need for our limit, our other limit with the a. Just plug it in. What about the slope at x equals -1? Well, 2 times -1 is -2. There's your slope. Let's look. At 3, at x equals 3, here's our equation, right? Here's our equation, x equals 3. Slope of 6, positive 6, right? Straight up and down, right? At 3, we have a positive slope like this. At -1, slope of -2, going down like that. That's at -1, slope of -2 going down. So it tells you any slope anywhere along the graph. Just plug it in and tells you the slope at that point. This equation is 2x equation. So this equation is a very powerful equation. This thing that we've done is a very powerful tool to get a general equation of the slope of a tangent line. Like tangent line slope formula. Tangent line slope, tangent slope equation. But that's like a mouthful. Tangent line slope formula equation. It's like too much to say. Tangent slope equation. This is too much to say. It would be nice if we had a better word for this, a single word, instead of tangent slope equation. And we do have a better word. That word is called the derivative. What we have found is what we call in calculus the derivative. The derivative is the tangent slope equation. We found the derivative. the derivative means it is the tangent slope equation of a function f of x. An equation that tells us the tangents of any location along some function f of x. So the formula again for the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. That's the formula for our derivative, the equation that we're using. So we can do this formula with any f of x equation. We can find the derivative, we can find the slope formula, we can find this derivative of any function we want. Right? It will tell us the slope at any point. So let me do another example. Let me go over here. So let's try again. For example, let's find the derivative of f of x equals 2x minus 3. No, hold on, not 2x, sorry. 4x minus 2. Okay. Find the derivative of this equation. So we're going to use our formula. The derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Right? So I'm going to plug these into my equation. My steps are, number one step, plug in, then simplify, and then step 3, do the limit. I guess I should put a step 3. Oh well. Step 1, plug in. Limit as h approaches 0 of 4 times x plus h, right? You see I plugged in the x plus h, minus 2. And I put little brackets around so I just can clarify. This is the first thing I did. I used the whole formula, x plus h, plug that in, minus 2, the whole formula. That's the first part. Minus, my second part is the regular formula, 4x minus 2. I put them in brackets like this so that I can remember that I have these two pieces, these two chunks. Okay. So first part with the x plus h, second part with x. Now I do my simplifying. Limit h approaches 0 of. This I just, I distribute my 4, okay, and I distribute that negative. So I'm going to get 4x plus 4h minus 2 minus 4x plus 2 over h. Right? So now, a few things are going to cancel. Like always, you'll have some canceling. This 4x is going to cancel with this negative 4x right there. Right? The only thing we want to have left is like h's. H's to cancel. And then this minus 2 is going to cancel with that plus 2. So all I have left is the limit as h approaches 0 of 4h over h. And, well, h over h is going to cancel. So I have the limit as h approaches 0 of 4. Where'd the h go? I don't have any more h's. My limit is... What's the answer to this? Well, what's the limit as h approaches 0 of 4? Well, there's no h, so it doesn't matter. This limit part's like not invalid. It just doesn't change. It doesn't matter. There's no h's here. So my answer is just 4. That's my slope. Slope equation. Just a 4. Why is it like that? Why is my equation just 4? There's no x here. So does this mean that no matter where my x value is, no matter what the x value is, my slope is always going to be 4? Slope, I should say tangent slope. Tangent slope. Tangent slope is always 4. And I was going to ask someone if they could explain why, but yes, Lizette, you are exactly 100% correct. Can you unmute yourself and explain to us why this is the case? Why? Yes, thank you. You're exactly 100% correct, right? This, thank you, this equation, this is 4x minus 2. This is f of x, everybody. And so in this situation, if I went, I don't know, here, for example, what is the tangent slope right there? Well, the slope of the line is always going to be 4. Tangent slope is always 4. No matter where I am on the graph, it's the same, because it is a line. Yes, exactly. Because my equation was a linear equation, the slope is constant throughout the whole equation. Very interesting, everybody. Very interesting. It's not a curve, right? It's not a curve. My slope isn't like changing as the graph goes around. My slope is constant. It's just 4 everywhere. Let's do another. What about another example? Zoom in a little bit. Let's do another example. Find the slope, or I should say find the derivative. Find the derivative. The derivative of f of x equals 7. My equation is f of x equals 7. What's going to be the derivative of that? Just a 7. Just a 7, everybody. So again, we have our limit. Excuse me, limit as h approaches 0 of f of x plus h minus f of x over h. So f of x plus h, well, I have to plug x plus h into the x in this equation. There is no x, right? There's nowhere to put this x plus h. So it's just going to be a 7. So it starts at 7. Again, there's no x, so I don't have an equation. It's just going to be minus 7 over h. So that's going to be, well, okay, limit h approaches 0 of 0 over h. What's going to happen here? This is one of those strange situations where we have like a, is it 0 over 0? Is it does not exist? Is it nothing? Is it, what can we do? Well, let's examine this line. What does this equation look like? What's the graph of y equals 7 look like? It's a straight line like this. This is the equation f of x equals 7, right? So if I ask you what's the slope of this spot here, what's the tangent slope? What's the slope of this line? Straight, horizontal, flat slope. What's the slope of a line that's flat? Anybody remember? What's the slope of a flat line? Correct, Jessica. It is 0. So when I have the limit is 0 over h, well, 0 divided 0, so my answer of this slope is going to be 0. And it is 0 everywhere. Just like before, my slope of a flat line, my slope of just a constant number is 0. Slope of my my linear line, is the slope, the 4, right? Because it's a slope, same slope everywhere. Same thing here with a straight line. My slope is going to be 0. We solve the equation. We see it's going to be 7 minus 7. It's just 0 on the top. So my slope is 0. All right. So you're getting this pattern. You're seeing the pattern happen, right? The same thing. We're doing the same thing over and over again. Plugging in x plus h minus f. We do some simplifying. We break it down. I wanted to show you those two weird situations. Sometimes you have slopes of 4 if it's linear. Sometimes your slope equation is 0 if it's just a straight constant line. Okay. So let me show you a little bit more complicated one now. Let's do one that's a little bit harder. Those were easy. Let's try this one. Find the slope equation. Again, slope equation. I should really call this the derivative. Find the derivative. Of the equation f of x equals the square root of x. What about that one? Follow the same rules. Same rules apply. Square root of x. So how do we do this? Again, limit as h approaches 0 of f of x plus h minus f of x over h. So let's plug in. I'm going to get square root of x plus h. Right? Put that in there. Minus square root of x. That's like my first piece, right? My first piece, second piece. over h. I should put limit here. H approaches 0. I should put the limit there. I want to make sure I'm writing all the right things. All right, everyone, we have a square. What do I do here? What do I do? What was our strategy for figuring out this square root thing? For how do we cancel this square root situation? What do we do for this? There's a word. I'm looking for a certain word. Not square it. No, I can't just square things. Jessica, I can't just square a number. I'm not allowed to just square things. Can't just square things. I have to do something. With fractions, I have to do the same to the top and the bottom. And I can't just square. It's going to make a different number. Conjugates, yes, thank you. The conjugates, yes. Square root of x plus h plus square root x on the top, and square root x plus h plus square root x on the bottom. I multiply by the conjugates. Radicals always work the same way. Conjugates. Square roots, you simplify them by using the conjugate. So I'm going to have the limit as h approaches 0 of top part. When I multiply these two together, it just becomes x plus h. The square root goes away. Right? Radical times radical becomes itself. And because they are conjugates, I know that this outside piece, this outside piece, where I did the square root times the x and the minus square root x times this, these two are going to cancel out. So I'm not even going to worry about the awkwardness of that weirdness. I'm just going to take the very last one, the square root times the square root, this one and this one. The first one, let me say this again. I don't need to worry about, if I'm doing FOIL, F-O-I-L, first, outer, inner, last, I don't need to worry about the outer and the inner parts. I just need to multiply the first pieces together and the last pieces together, because the middle ones are going to cancel. So root x times root x is minus x over h times, I'm not going to multiply the bottom parts, I leave it alone, plus h plus radical x. Okay? Middle parts are going to cancel. Middle parts cancel. So I'm just left with the first times the first and the last times the last. If you want to work it all out, you can, but just the middle parts are going to cancel. So I have this here on the top. Now, again, I have some things that cancel, like x minus x. The x's are going to cancel each other out. So I have the limit as h approaches 0 of h over h times radical x plus h plus radical x. And my h's cancel. Look at that. There's the h going away. That's what I wanted. Oopsies. So it is the limit as h approaches 0 of 1 over radical x plus h plus radical x. So I plug in my 0 now. It's going to be really nice. I get just square root of x plus square root of x, which is 1 over 2 square root x. And that's my equation. That is the derivative. Like I plugged in a 0 here, it's going to be like, right, this is just plus 0. But I really don't need to write that 0, right? It just kind of goes away. I don't really need that 0 there, right? The plus a 0 doesn't really matter. Whoops. So it's just root x plus root x, which is 2 root x. Add them together. All right, everybody? Feeling good? Here's our formula for a derivative. Our second big piece of calculus is finding these derivatives, these equations of our slope tangent. For the square root equation, it's this 1 over 2 root x, and we found that by following through with our formula here. Okay? So you're going to spend some time practicing these. Your homework, which is going to be due next week. Out of the book, page, what do I say? 107. Numbers 15 through 27 odd. 15 to 27 odd. It's like 6 problems. 15 to 27 odd. It's page 107. 107, 15 to 27 odd. It's practicing finding these derivative equations. Practicing finding these derivative formulas, these equations for finding the slope of tangent lines. And once we have the equation, the general formula, we can find any slope, right, at any point by just plugging in. That's what we did today, folks. We found the general slope of curves. General slope of curves by finding this derivative. What's happening here? Oh God. Finding our derivative formula, right? Instead of finding it lots of times, we just found it one time using this H formula. Right? This formula here for our derivatives. Questions, concerns, worries? Mr. Mitchell, can you show me that thing over there? I forgot how to do this equation. I couldn't see what you wrote there. It's okay? All right, everyone. Well, that's it for us today. Thank you all. Practice this over the weekend. It's going to be due next week. These 6 questions, just practice this derivative stuff. The only way to do it is to get better is to try it. But that's it for us. Hope you all enjoy your days. I'll see you next time.